Hey everybody, welcome to another video. Today I'm going to be working on this Ethereum Bluetooth digital radio, which I managed to find at a car boot last Sunday for £5. The seller, the person who was running the car boot, said that it worked, but unfortunately it didn't, which is kind of what you expect when you go to a car boot, to be honest with you. The majority of things, especially electronics, don't tend to work, but I actually quite enjoy them because it means I get to do stuff like this really cheap, and also get some really cheap power tools. I recently picked up a ripsaw, which I managed to fix, or somewhat fix, and that was really cheap as well. I paid £4 for that, but that was a Ethereum ripsaw as well. So yeah, I saw this and I thought, you know what, I might as well give it a try. It was up for £10 and I said, well, I'll give you £5 for it, don't know if it works. He said, oh, it worked, but yeah, I'll take £5, but yeah, it doesn't work. So I tried it, I plugged it in, I gave it a power source, 12-volt power source, and nothing, just completely dead. So with that being said, my name is Lakota. I'm an electronics technician and I mainly work on games consoles, but sometimes I do other things too. And I'm trying to get into a wider array of repairs just to keep the channel interesting and stuff like that. But I will say that I don't work on tools and stuff like this for actual work, for the general public. So please don't send them in to me because I'm not interested in repairing them for a living. So if you are new to the channel, don't forget to get subscribed, turn on the bell notifications, all of that good stuff, and let me know in the comments what you want to see me work on next, and I'll see if I can possibly find one to repair. So with that being said, let's get into this video. Today's video is sponsored by PCBWay. Whether you've got a simple project that requires a quick mod board or you want to launch your own products to the world, PCBWay can help. With fantastic pricing on multi-layer PCBs, flex PCBs, 3D printing and even laser cutting solutions, you're sure to get everything you need all in one place. Custom PCBs start from just $5 for a 1 to 2 layer board with a fast 24-hour build time and free shipping on orders over $30. PCBWay are also proud to announce their new aluminium PCBs, which start at just $120 per square metre. Check out what PCBWay have to offer by clicking on the link in the video description or the top pinned comment and get your project started today. Thanks again to PCBWay for sponsoring the video. Let's get back to the repair. Right, so as you see, we've got the radio here. So this is supposed to be a portable radio that you put onto job sites and stuff. Honestly, Ethereum are more of like a hobbyist thing. You don't really see professional tradesmen using Ethereum, to be honest. They're pretty cheap. I think they're owned by Screwfix. I'm not sure, but B&Q also sell Ethereum stuff as well. But I think the actual brand is owned, like it's a subsidiary of Screwfix. So yeah, it's one of those things. I have got some batteries, but for some reason they don't fit in this one. So I think it takes a different model battery. But if I get this working, then I'll see if I can source a battery cheap, and if not, then I could always use it on main DC input. So yeah, there we go. But yeah, like I said, this doesn't seem to power on at all. I haven't tried a battery. I could give it 18 volts off my bench power supply just to see if it works on battery. Like I said, I didn't have a battery to actually try it with, so I couldn't actually do anything. But yeah, it is what it is, I suppose. And the first thing I'll do is just, well, basically check my pins and just see which pin is going to be the positive. I'm pretty sure that this left pin here is positive. I'm not 100% sure, but what I'll do is, if I just look at my multimeter, you can do this a couple of ways. You can check in DC voltage mode, or you can check continuity by opening it up as well. But if we look on DC voltage, if this comes up with a negative, then chances are we've got the polarity incorrect. So my positive lead there, negative lead there, and that looks to me like, well, it looks like a dead short actually, to be honest. So it's reading around about 0.0010 volt DC. That's really low. I can check the resistance on that. It looks like that is the correct polarity and that is neutral, negative, sorry, not neutral. I can check the resistance of that and just see what the deal is. Oh no, it's not actually. It's not short. 17 million ohms. How about that one to that one? 2 million ohms. How about that one to that one? 30,000 ohms. I'm not going to actually inject voltage on this. I don't think it's going to be worth it because I don't know what pin is which. I've just changed my mind on that. So I'm not going to inject voltage. I can always check which pin is which on the bench power supply at a later time. And, you know, sorry, not on the bench power supply, on the multimeter. I can trace it out when I'm actually inside. So I'm not going to do that for now. Interestingly, we've got a couple of things on here. We've got a second USB port and then a second auxiliary in as well. That's quite cool. But yeah, it's obviously quite dirty and whatnot, but that's not a problem. You know, I can always give it a clean afterwards. Yeah, like I said, I've tried it with a 12 volt power source and we don't seem to get anything. So it's 12 volt 1 amp, so it's not really difficult to find a power cable for it. But I will just try on my microscope cable. So if you look just there, well, if I can get it into shot. So my microscope is obviously on. This is actually outputting 12 volts on the microscope. So yeah, basically what I can do is just pop that into there. So obviously this cable is working. And we get absolutely nada. So nothing at all happens. Nothing whatsoever happens. So yeah, completely stone dead. Let's get it apart then, shall we? So to get it apart, it looks like we've got some hex bits that we're going to need to remove. Okay, so it's fairly clean inside, to be honest. Not bad. Not bad at all. So there's really not a lot to these. You got basic power management, and then obviously you got your radio receiver, a little bit of logic for playing the music and stuff, and then yeah, that's pretty much it. So let's have a look. Okay, so I was right by the look of it. Actually, no, that could be a... Yeah, it was, yeah. So you got negative there on the end, the single pin on its own. And then you got positive on the right-hand side, and then this is going to be a feedback wire, this black one. So, yeah, from there I could inject voltage into it and just see if it actually wants to fire up. Let's do that actually, that sounds like a good plan. So I'm going to start off by just popping 1 volt into this, just because I don't want to go straight full ham and give it 18 volts, right? Because if there is a problem, I don't want to burn anything out that I don't, you know, that's not burnt out already. So if I just put 1 probe on the negative wire, 1 probe on positive, and we don't get any kind of current draw, so I don't think there's a short there. So now I can jump up to the 18 volts that it requires. We get absolutely no parasitic draw from that at all. There's no current draw right now. Huh. Okay. Maybe jump a little bit. Okay, so it's starting to turn on, but it's just basically power cycling. Saying that the battery's dead, but I'm assuming that's probably because the feedback wire isn't there, I'm assuming. We do get some signs of life, but then it just basically reboots itself. Interesting. What about the actual DC jack? What about if I supply that with 12 volts manually? No parasitic draw. So by parasitic draw, I mean basically nothing's happening with the bench power supply. It's not drawing any current, which is what you would expect when it's turned off. It's going to be a little bit tricky. No, absolutely nada. Okay. So I'm assuming that this is the power supply, this little board here, and then all of the logic is going to be on this board. So I'm not sure where to start, to be honest. Right, okay, so looking at this closer then, that resistor there doesn't look exceptionally well, does it? So there's really not much to this. We've got a 4407 transistor, that's going to handle the switching, I assume, and the voltage regulation, and that's pretty much it. There's not really much to it other than that. I mean, it could just be a cracked solder joint, but I don't know. Then again, I mean, yes, it doesn't look great, but that resistor, it looks physically connected and it doesn't look damaged. So it's not perfect by any stretch of the imagination, but I don't think that's going to be the issue. It's probably going to be something to do with the chip itself, if I'm being honest. Just given... then again... don't know, it don't look great. In fact, it looks like we've got some corrosion on the actual jack as well. Alright. Yeah, none of this really looks good. So it looks like we've got some possible signs of liquid damage. So what I'm going to do is I'm going to clean all of this up. And I think I'm going to basically just resolder all these joints to start with, because they don't look great. I mean, it might not work, but it might work as well. So, yeah, let's have a look inside the jack. The jack doesn't look terrible. I'm hoping I don't have to replace that because I don't have any. So I'll just chuck a bit of IPA everywhere. So I want to get rid of any kind of mess first before I go resoldering joints. Plus that, I'll get rid of some of the corrosion as well. So it looks like we might just have a little bit of liquid damage on it. That's just started to kick in and it's causing it to make a contact issue or something. I don't know. You never know. It could be nice and simple. We might actually get an easy one for a change. So I think with the battery as well, you know, the fact that I had the battery plugged in, or rather replicating a charged battery, the fact that it was shutting straight off, I think that could be something to do with the fact that we didn't have a feedback wire on it, you know, to tell the logic how much charge was in it. So it was just automatically shutting off to prevent, to prevent it from discharging too much. And I don't think there's actually an issue with the main board itself, personally. Alright, so that's nice and clean. It's nice and clean everywhere. So I'm going to add some flux to it. I'm just going to resolder everything. I'm just going to run my iron across everything and just give it some fresh solder. Essentially reflow everything, because the joints don't look great. They look like they're starting to oxidise and stuff, especially that resistor there. So a little bit of fresh leaded solder might work wonders. Alright, so there's those done. Let's just flip it around. And I'm going to resolder all of these joints as well, just to freshen it up a little bit. It's not going to hurt to just redo the joints. Okay, so that's pretty much done. Good. So we've got some nice fresh solder joints there on that. I'm not sure if this is actually going to help it, but it's got to be worth a shot. Just given the fact that the joints just didn't look great at all. So I'm just using 99.9% isopropyl alcohol, by the way. Okay, there we go. So that's looking a lot better now. It's looking a lot cleaner. So hopefully that's going to give it a new lease on life, but we'll see. I haven't got any DC jacks, which is why I'm hoping it's not the DC jack, to be honest. I mean, it's not difficult to change them, but I just don't have any, so I would have to order one and wait. And I hate waiting when it comes to making videos and stuff, because I end up losing footage and stuff like that, and yeah, it's not fun having to do multi-part videos and stuff. So I'd rather fix it all at once and move on to the next thing, I guess. Okay, so that's ready for testing now. No. Absolutely nothing. I don't think it's anything to do with the polarity on the wire. I have tested this with multiple cables, by the way. Let's try it with the bench supply then. Nothing. Okay, that is turning on. But nothing from the DC jack. It's got to be the DC jack then, right? Surely. It's either that or one of the diodes have failed. Nothing. Dead. From the DC jack anyway. What about off that diode there? Okay, it works off that diode. So I'm not sure if you can see the light actually on there. You know, you can actually see through the PCB from the LCD. What about off the resistor in the middle? Nothing. Nothing. That's rather odd. I mean, I could run a wire straight from the DC jack to here, but I don't really want to do that. Right, so let's test these diodes first. So I've got the meter in diode mode. I'm going to pop my black probe on the input side of the diode. So there's a line on the diode, and that indicates the input side. And we get 0.14 volt drop there. How about the other side? So if I flip it in reverse, yeah, we get open line. So that diode is working. What about this one? 0.14. And if I flip it in reverse, nothing. So those diodes are both working. So the way a diode works is it basically prevents current in one direction. If we get power coming from here, so this actually looks like a MOSFET, given the fact that 4 pins are connected together. So if we get power coming through this MOSFET, it's going to travel through this diode here, but it doesn't want to backfeed, right? So basically, if you've got power coming from the battery, and I'm assuming that this diode is going to be for the DC jack, so if you've got power coming from the battery, so that's going to be coming from this MOSFET here, then you don't want the power to basically backfeed into the 12 volt jack. So if you plug in a jack, you don't want it to power, you don't want 18 volts from the battery going into the 12 volt power jack, right? So what they do is they put these two diodes here, and that prevents the current from going both ways. So if you get, for example, 12 volts coming in through here, it goes through here, but because this diode's here, it cannot travel this way. So only power from here can travel through here and into the main board. I think what I could do is I could just bypass this completely and run a wire from here on the jack to this side of the diode. I don't know if I want to do that, but I don't see much of an alternative at the moment. And then maybe post a video and see if anyone's got any ideas. That's an option, I guess, because I can't think of anything else. So I think I'm going to do that, just to get it working. It's only going to be me using it. I'm not going to resell it or anything. And I'll probably only be using it as 12 volt supply anyway. I probably won't buy a battery for it because it's not really worth it for the cost of them. So I'm going to solder a wire to here. I'm going to do the naughty thing and just get it working. Something wrong somewhere, but I just cannot figure it out. I'll solder that onto there. And then I can come onto this MOSFET here, right? Because, well, the MOSFET goes to the diodes anyway. Right, so as long as that's not touching the resistor, we're fine. I'll just trim that off, clean it up, and that should be okay. So all I'm doing is just bypassing the MOSFET completely and allowing it to take a 12 volt input, I suppose. Let's try that. So I'm going to be clear here as well. I don't know what I'm doing with these things. I bought this just for a bit of fun, and I've never worked on one before, so yeah. Maybe someone in the comments will know how it actually works, and well, maybe someone has come across it before and can point me in the right direction, give me a bit of an idea of what the frickin' I'm supposed to do here, apart from bypass it or try and find a replacement PCB. Yep. Okay. Right, so is it not supplying enough power? Because that's not meant to happen, and we're not getting anything. So there are other issues with it. Well, that's not good, is it? Now I don't know what to do, because there are more issues with this, and I don't know if it's going to be actually worthwhile to do anything with it. What about if I give it the 18 volts rather than the 12. Does that work? Is it not boosting the voltage? Because it looks like it's trying to fire up and it's not. So is it just not boosting it? No, it's still doing it. I think, well, that chip there is getting warm. Just there. So, I'll leave a link to this thermal camera, by the way. It's a really, really good thermal cam. Yeah, we've got some definite signs of heat down here. Oh, actually. Could be something to do with the transistor, maybe. Oh, wow, that does get hot. Look at that. Yeah, that chip, look at that. Oh, man, I don't think this is going to be fixable. Oh. Okay, actually, you know what? We've got a diode getting warm there. We've got a transistor getting warm there. This could literally just be power related, couldn't it? All of the heat is focused around a diode there. And this area here. So that transistor. Oh, that transistor don't look good. Yeah, that transistor don't look good at all, does it? Look at that. This transistor here looks a bit damaged. It does look a bit damaged. I'm going to remove this, but I'll have to remove it without the microscope because, well, it's a little bit difficult. And then I can look at it under the microscope afterwards. So I'm going to have to try and figure out what the part number is to this anyway, if it is damaged, so yeah. So I'll just pop this to one side, bear with me. Okay, so you can see what I mean when I said that it looks a bit damaged. It don't look good, does it? AMS 1117. Look at that there. Like, that wasn't me while I was removing it. I noticed it before I removed it. Well, I don't think there's anything I can do right now. I think what I need to do is maybe source one of these transistors, because apart from that that logic chip, whatever the hell it was, probably going to be some sort of a controller on the main board itself. I don't see anything else getting hot, and that does actually look a little bit iffy, right? So I think I'm going to source one of those transistors, see if I can find one somewhere. Obviously this isn't going to turn on now because, well, I've removed the transistor. So yeah, obviously completely dead. But that being said, I think what I'm going to do is I'm going to source one of those chips, those transistors. I could inject voltage into that middle pin. That's an option, I suppose. Just quickly and just see if it actually powers on. So I'm not going to give it 18 volts, I'll give it 12. Ooh. Whoops. That weren't meant to happen. It's just let out the magic smoke. Oh no. Oh, I've just fried that chip there. And that's going to be something to do with the LCD controller. Ah, damn it. That didn't exactly go to plan, did it? I've just not only got to find one of those transistors, but now I've got to try and find one of those LCD drivers as well, because yeah, I don't think that was meant to have 12 volts, was it? This is why I don't work on them professionally. Well, we all make mistakes, don't we? I'm going to leave it there. I'm still going to post this video because my videos are honest and I show things the way that they are. I don't hide anything from anyone. I'm not an expert when it comes to these things, and I'm not even competent when it comes to these things, apparently. So maybe I should stay away from them. Thank you all for watching. I really appreciate it. Let me know what you think in the comments. Have you worked on one of these before, and do you have any idea of what it could be? If I manage to figure it out, I might do a revisit on it, but I've got to try and find some of those chips first. So, yeah, it might end up on the scrap, to be honest. It cost a £5. It was a bit of fun. Whatever. Yeah. Thank you all for watching. I really appreciate it. Take care, everyone, and I'll see you all in the next video. Subscribe for more Magic Smoke. Bye for now. All I wanted to do is listen to Taylor Swift.